Okay, now for what we have in the last of the problem set, we have two functions. One is a cubic root function where we have f of x is equal to the cubic root of x minus 3. Then we have another linear function, this time where we have g of x or y is set equal to x minus 3. And it says here to sketch the region bounded by the graphs of the function. So it could be any one of these four possibilities. And we'll find out just which one of these four it will be. Now, so if we set these functions equal to each other, we can say that we have the cubic root of x minus 3 is equal to x minus 3, and we can get rid of the radical cubing both sides. And the cube of the right hand side, okay, this will become a 4-term polynomial, whereupon we have x cubed minus 9x to the second plus 27x minus 27. And if we set this up as quadratic in standard form, we can take away both x and the negative 3. So you can see we have 0 is equal to x cubed minus 9x squared plus 26x minus 24. We're putting this as a cubic in standard form. Alright, now in terms of what we have here, this is not a cubic that we can factor by grouping. Okay, but some things we can use as a reference point. Okay, now we have x minus 3 embedded in the cubic root radical, and we have x minus 3. So both these have x minus 3 in common. So we do know that one value of x in which both sides will be equal will be the 0 that will be applied to these, and this will be when x is 3 and both sides will be equal to 0. And if you were to say attain a 0 with 3, and I'm going to look at treating this along the lines of synthetic division. So you can see we have a 0 value at 3. We have 1x cubed, negative 9x squared, then we have 26x, and then we have negative 24. In case you're wondering, I'm not asking that you know synthetic division. In fact, you can attain the points of intersection, okay, with a graphing calculator, but just for the old school practice. Okay, so with synthetic division, okay, leading coefficient we have at 1, and if we will bring this down, we have taking the product, okay, of the zeros. So we have 3 times 1 is 3. Negative 9 plus 3 is negative 6. 3 times negative 6 is negative 18. 26 minus 18 is 8. 3 times 8 is 24. Negative 24 is 24. Okay, that's going to be 0, so there is a 0 remainder. Now if you notice, 1, negative 9, 26, and negative 24 were the coefficients of this cube. And as we draw out a 0 factor, okay, what happens with the dividend that is left over? Okay, this can go down a degree, whereupon we have 1 is going to be in reference to x squared, negative 6 will be for minus 6x, then 8 is going to be for plus 8. And so if you were to consider that 3 is a 0 from x minus 3, okay, this whole expression, okay, from 3, if we factor this cubic, we have x minus 3 times the quantity of x squared minus 6x plus 8 is equal to 0. And this trinomial can be factored. Okay, so you have x minus 2, x minus 4, And so for the resulting values here, now we'll put these in ascending order. Okay, so you have 3, 2, 4. But for the x values, have from x minus 2, x is equal to 2. From x minus 3, x is equal to 3. From x minus 4, x is equal to 4. And if you were to put back into either expression, 2 minus 3 is -1, 3 minus 3 is 0, 4 minus 3 is 1, and you're just going to follow that for the points of intersection. These will lie at 2, -1, 3, 0, and 4, 1. And out of all 4 of these possible graphs, looking at how they are lined up, okay, it's definitely not going to be these two, because we're looking at linear function with a positive slope, so second and fourth graphs will be eliminated. Okay, and we have well, this is the x values are off in the case of the third graph, and so the result here is going to be this particular location: 2, -1, 3, 0, and 4, 1. And so we have, in the case of the activity that occurs, if we were to look at the determination of the area, okay, notice there's a bit of a role reversal. Okay, say we have going from 2, -1 to 3, 0 to 4, 1. Okay, notice we have y is equal to x minus 3 is going to be above the cubic root function. If we take integrating with respect to x, taking vertical slicing, okay, the linear is above the cubic, but as we get past 3, 0 on out to 4, 1, okay, this time we have the cubic is going to be above the linear, and we will refer to this region as R2. And so with what we have in configuring the area, so for R1, okay, going from x equals 2 to x equals 3, the linear function is above, so we can say we have x minus 3 minus the cubic root of x minus 3, or we can just call this x minus 3 to the 1/3 power. And as for what we have in the second region, again, the cubic root is going to lie above as x goes from 3 to 4. Alright, and so far as what we have for the area itself, no like terms are going to be combined. No sign changes will occur. Okay, so I'm going from x equals 3 to x equals 4. Okay. We have x minus 3 to the 1/3 distribution over the binomial. From the linear function, we will have a minus x plus 3 dx. And so, using the power rule of integration, okay, we have x squared over 2 minus 3x for x minus 3 to the 1/3 antiderivative. We want to have it minus 3/4 of have x minus 3 to the 4/3. As we proceed from 3 to 4, again we have the antiderivative. This time we have 3/4 of x minus 3 to the 4/3 minus x squared over 2 plus 3x, as x goes from 3 to 4. And with the corresponding values that we are going to have, I'll just go ahead and lay this out. Okay, for the upper limit, okay, we have 9/2 minus 9 minus 0. Lower limit, you have 2 minus 6 minus 3/4. And that's from the R1 portion. And then working with the R2 items, whenever x is equal to 4. Okay. In this particular instance, okay, we're going to have 3/4 minus 8 plus 12, and with 3 at the lower limits, okay, 0 minus 9/2 plus 9. And as you look at combining all the terms together, okay, the resulting area amount in this particular case, alright, we're going to come out to the combined total, whereupon the area is going to end up at 1/2.